Okay guys, so in this lecture we'll be continuing on seeing some more examples on the decarboxylation reaction. Okay, so let's get started. So we have first example as what happens when we heat this compound. It's again geminal dicarboxylic acid. On heating, obviously it will evolve 2 moles of CO2 gas with this compound as the product, 2 moles of CO2. Okay, next we have something like CH2CO2H, then C double bond O and CH2CO2H, which on heating, what compound do we get on heating this what product do we get on heating this compound? Obviously we will be getting the CO2H would be removed, and 2 CO2 would be removed, and we'll get something like this as the final product. What happens when we heat this compound? We have H and H here, and geminal dicarboxylic acid. On heating it would form anhydride, as we have already mentioned in the previous lecture. So we'll get something like this as the final product. Okay, what happens when we heat this compound, or rather first let's just pass it in acidic medium and then we heat it. So when we pass it in acidic medium, obviously first step will be getting something like this, and then when we provide heat we will be getting a CO2 gas evolved plus ketone. Okay, what happens when we treat this compound with first acidic medium and then CO2 ET, and it is also CO2 ET. First let's just hydrolyze it, then we heat it. So what will happen is, so we'll get OH here in place of OCS3. Why? Because the on H plus getting attached with H plus, this bond would be broken up and resulting in a positive charge here. Later OH will act on this carbon atom, and finally we'll have OH and OCS3 here. Okay, then again H plus will be taken up by this oxygen atom. It will again acquire a positive charge. It will again leave this bond, creating a positive charge here. Again we'll have something like water, OH from the water molecule will actually attack on the carbocation and forming a geminal diol at this carbon atom. Okay, and here also we'll get something like CO2H and CO2H. Okay, so on heating this compound, what will we be getting? We'll be getting ketone here and CO2, 2 moles of CO2 released. Okay, okay, so let's actually look at this example. This is an important example. If you want this example to include it in your notes or somewhere, or you again want to revisit this video lecture, you can take a look at this example and can fast forward it then. Okay, what happens when we take this compound and we heat it? Okay, what will we be getting? We'll be getting like a meso compound, anhydride. Okay, whenever geminal dicarboxylic acid react, we get anhydride, and in this case it would be meso compound. Why? It has a plane of symmetry. Okay, now let's discuss another example where we have something like this. Okay, CO2H attached on the same carbon atom. On heating, what will we be getting? We'll be getting something like this and 2 moles of CO2 released. Okay, let's look at another example. If we have something like this and C14 here and OH, on heating what will we be getting? We'll be getting something like A product, let's say, and on A product if we again pass NaOI, we get product CHI3. So you have to determine product. Okay, let's say you get product B plus C. So we have to identify product A, B and C. Okay, So what will be product A? When we heat it, we will be actually getting something like this CS3 plus C14O2 released. Okay, this will be product A. Okay, and on this, when we are applying again NaOI, what will be happening? Chloroform reaction will take place, in which CHI3 yellow precipitate will form, and along with that, what else would be forming? We'll be getting a acetate ion, or rather carboxylate ion in a general way. Okay, let's look at another example. Here we have something like this, and there is a methyl group here and double bond O CH3. We are passing it first with NaOI, and second we are providing acidic medium, and thirdly we are providing heat to it. So what will we be getting? We will be getting something like this from the first step. Okay, plus obviously CHI3, the yellow precipitate will be formed in the second step. When we are providing acidic medium to it, we will be getting something like this, or carboxylic acid will be formed. And third, when we are heating it, what will we be getting? We will be getting ketone group, and CO2 would be released. Okay, let's look at another example. In this example, we have something like CH3, CO2H here, and ET here, and again CO2H here. So on heating this compound, we get, let's say, product A and B. So what are products A and B? That is the question. So product, obviously B would be obviously a CO2 gas evolution would be there. Okay, and product A would be OH and CH3H and ET here. Okay, so this would be product A. Okay, so what else can we get from this? Obviously this will again heat up, and we can get something like H and CH3. So again 2 moles of CO2 can be there. Okay, let's discuss another example where we have something like, again, 2 CO2H attached on the same carbon atom, or in other words, it's a geminal dicarboxylic acid. Then what will we be getting? So again we can get the same thing plus CO2. Okay, obviously you can add 2 here. Okay, so let's look at the last example. We have, suppose, X moles of beta keto acid. Okay, including stereoisomers. Okay, and we react it to get we heat it rather to get 2-methyl cyclohexanone. Okay, so what is X? So 2-methyl cyclohexanone is nothing but this compound. Okay, so we can either get this compound from, what should be the, this is the final product, so what should be the reagents or substrates, final product rather. So we can have, we can use beta keto acid. Okay, so we have a condition over there. So beta keto acid would be something like this. We can either have this, or we can have something like this. Okay, so how many stereoisomers can it have? 2. And how many it can have? 4. Why? 2 chiral centers are there, 2 to the power 2 is 4, hence X is equal to 2 plus 4, which is 6. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing soda lime process or oak wood process, and then we'll be moving on to ozonolysis. So till then, good luck and goodbye.